kita mengira losses adalah HF, F, L over square, V square over 2G. Kemudian kita boleh substitute value velocity here, the value of velocity here with the Q square over A square, because we know Q is equal to AV, and then we substitute into this one, and then we could rewrite this equation, and then we could simplify this equation into K and Q square. So, and then the idea of Hardy-Cross method is if we calculate the losses, whether it is clockwise or counterclockwise, the value must be equal. Okay, so and then we develop the equation for clockwise, and it will become like this, and then the equation for counterclockwise is like this one. Okay, so and then we assume that the losses for clockwise must be equal to the losses for the counterclockwise. So and then okay, so this method we need to do try and error method. Means first we need to guess what is the flow rate, and then if the calculation is not balanced, what we need to do is we must reduce a little bit from the unbalanced one, and then we need to top up with the notes. We need to top up from to the other side. So cara ini ialah dengan menggunakan try and error method. So first awak kena beri numbers, and then awak akan lihat sama ada dia balance atau tidak. So sekiranya tidak balance, tidak seimbang, apa yang perlu awak buat? Awak kena ambil bahagian yang banyak, ambil sedikit, dan awak kena top up pada bahagian yang sikit. So that's why in this equation we need to deduct so we assume that the clockwise amount is larger compared to the counterclockwise amount. So what we need to do is we need to deduct a little bit flow rate at clockwise area, clockwise side. So that's why we deduct this one. So means we have QC minus delta Q square. So here delta Q here you must remain as a delta Q because there are no delta QC and delta QCC. So the amount of delta Q actually constant. So we have delta Q at the left and also delta Q here at the right. Okay. So and then we need to expand this equation, and then we neglect the delta Q square because the amount is too small, and then we could rearrange this equation into this term, and then to simplify this term, so we can substitute with this term, which is losses is equal to KQ square, or KQ is equal to losses over Q, and finally we could get this term. Okay, and please remember how to derive this one. Okay, and then please also remember the equation of this one. So and then so we want to discuss about the delta Q here. So the delta Q is the difference between the difference of your calculation between clockwise and counterclockwise. So the delta Q is not the final answer. The final answer is the flow rate. Delta Q is actually the difference of flow rate from pipe A and pipe B, for example. So that's not the final answer. So what you need to do, I will show you in the example. But the idea is you need to use delta Q as the indicator. So the indicator whether your calculation is good enough or you need to do same calculation for the second time or for the third time and so on and so forth. So delta Q tu hanyalah sebagai indikator, petunjuk sama ada jawapan awak telah menghampiri jawapan yang accurate atau tidak. sekiranya delta Q awak masih lagi besar, membawa maksud jawapan awak tidak accurate. Okay. So saya akan tunjukkan dalam contoh. So in this okay, so let's say we have this equation, this question. So let's say we need to determine the distribution of flow rate. So this is the pipe network. So for example, we have one inlet, so which is 100 liter per second, and then it's split into two pipes. Okay, and then for this example, I give you the value of K, mean that the total losses, the total resistance is K equal 2, and this is K equal 1. And then at this point, it's split into three pipes. One is outlet, which is 25 liter per second, and then another two pipe like this one. And then at this point, it's split into two, and this pipe is merged with this pipe. Okay, and then another pipe will go like this, and then merge with this pipe, and at this point, there is another output, which is 75 liter per second. Okay, so this is the basic step that you need to do to solve this problem. First is to determine the loop or cycle. So I will show it later. And then you need to predict the initial flow rate and its direction. No need to convert into SI unit. So mean of this one is, if the question gives you liter per second, so it is okay for you to use liter per second. Do not convert. It is okay not to convert the 25 liter per second into meter cube per second. So you could use liter per second or feet cube per second in this calculation. So and then you need to create table, and you need to fulfill with a Hardy-Cross method equation. Okay, and then you need to redraw the figure. Redraw the figure means you need to redraw this pipe network figure, and then you need to propose your new flow rate. Okay, and again, I write here delta Q value is not the answer, because in this calculation you will get the value of delta Q, but delta Q is not the answer. Delta Q will not bring you any marks if you just write the final the delta Q that you get from the calculation. So it will be 0, because delta Q is not the answer at all. Okay. So the answer is, because the question is to determine the distribution of flow rate. So means your answer is you need to determine what is the flow rate for this pipe, what is the flow rate for this pipe, and this pipe, and this pipe. So means because we have 5 pipes here, so you need to propose 5 flow rate for each pipes. So the flow rate for inlet is given 100 liters per second, and these two output is 25 and 75 liter per second respectively. So no need to calculate the flow rate for the output and input. Okay, so when we could, how delta Q indicates you. So if the delta Q is bigger, is still big, the value is not appropriate to take as a good reference. So you need to repeat step 1 until step 4. You need to calculate this again for the second iteration. If the delta Q is still big, so you need to do your third iteration, and might be the fourth, the fifth, until you will get the delta Q which is very, very near to 0. So if you get delta Q is 0, you get the perfect answer, but that will take so much time. So I will tell you what is the range that acceptable for this subject. So and then again, the delta Q is not the answer. What you need to do is you need to propose the new flow rate as your final answer. So for example, if you repeat these steps for 5 times, so means that you need to propose the new flow rate at the end. After you are doing the calculation 5 times, then you need to propose what is the flow rate for each pipes. Okay. Okay, so next step. Okay, this is the first. Okay, I just make it bigger. Okay, first you have this. Okay, this is, for example, this is for the first trial. So what you need to do first, you need to determine the loop. Okay, what is the meaning of loop? Okay, as I said previously, if we have a pipe network there, so the calculation of losses is equal whether we calculate it counterclockwise or we calculate it counterclockwise. So what we need to do is, if we have a pipe network diagram like this, okay, you just imagine that we have one loop here because this is a closed loop. Okay, so we need to calculate whether from here to here and here, or from here to here and here. And then another loops is this one. So we have this, whether we want to calculate it counterclockwise or we need to calculate it clockwise. Okay. And then to be safe, so I propose you to draw a rotation of loop like this. Okay. Okay, that is the first thing that you need to do. So you need to determine the loop. Okay, so that's about the determining the loop. So, and then please take care of this. If it is clockwise, so we assume that the flow is positive. If it is counterclockwise, we assume that it is a negative flow. It is just to show the direction of the flow only. So, and then step number 2, you need to give assumption. Your first trial, you need to give a first reading of the flow rate. Okay, for example, we know that the inlet is 100 liters, and then up at this junction, it's split into 2, and then you need to split the value of 100 liters here because it is a parallel pipe now. So it's split into 2. So it depends on you. So for example, first guess, I would like to say that for this pipe, so it is 60 liter per second, and this pipe is 40 liter per second. So please bear in mind that these two value, okay, if you add these two value must be equal to 100. Okay, because it's split into 2. Okay, so at this moment, so it is okay. If you want to start with 50-50, it's okay. If you want to start 70-30, it's also okay. Okay, and then I just give you hint. Okay, so if the resistance is bigger, might be the flow rate here is a little bit lesser compared to the pipe that have lower resistance, because velocity has fluid has tendency to flow to the pipe which has lower resistance. Okay, but that's not actually not it gives you some idea about the fluid flow. So let's say because the difference is not too high, so I just split into 60 and 40. So and then okay, at this point, okay, it split into 3. So we have a 3 here. And then you must alert that input here is 60, and this 60 liter per second need to be split into 3 junction. And the output is 25 liter per second must be conserved. So means that at this joint, at this pipe, it must be 25 liter per second. So the balance is 35 liter per second. Then that 35 liter per second, you need to split within these two pipe. So let's say I say that okay, might be this is 15 liter per second, and this is 20 liter per second. So mean if you total up these three value, 15, 20, and 25, so the total is 60 liter per second. Okay, I hope you could get that. So and then at this point, So at this point, you will receive two input, which is one is 40 liter per second and another one is 15 liter per second. So mean 40 plus 15, so the total is for 55 liter per second. So and then at this point, okay, at this point, for example, here, so you have two input, which is 20 and 55. So that's why the output is 75 liter per second. Okay, you must understand that the flow rate is showing the conservation of mass, so it cannot disappear along the pipe. So the conservation of mass or the flow rate must be conserved. So means the flow rate at inlet must be equal to the flow rate at outlet. Okay, but tapi awak kena berhati-hati, kadang-kala berlaku kekeliruan pengiraan kerana pada poin ini, okay, pada poin ini awak hanya perlu mengira tentang input yang masuk sahaja, bukannya 100 liter per second. So input yang masuk 15 campur 40, oleh itu total dia akan menjadi 55 liter. Okay. So campurkan lagi 55 dan 20, dia akan menjadi 75 liter per second. Okay. Yang ini saya harap awak dapat faham tentang agihan agihan kadar alih. Agihan ini bergantung kepada awak. Kerana ini adalah first trial, so maknanya kita akan memberi satu nilai anggapan kita, sebab kita akan buat iteration ini banyak kali. Okey. So kemudian kita ingin membuat pengiraan. Okay. So first kita kena lengkapkan jadual ini. So saya harap awak dapat membuat jadual, awak tuliskan branch. Maksudnya setiap pipe yang kita ada, awak berilah nilai A, B, C, D. Okey, kemudian awak kena faham bahawa kadar alih dia akan ada arah. Walaupun kadar alih adalah skala, kadar alih bukanlah vektor, tetapi secara realitinya kadar alih perlu mengalir pada arah yang tertentu. Jadi ketika awak beri 60 liter per second ini, awak kena berikan anak panah. So katakan anak panahnya di sini, yang ini mengalir di sini. So yang ini mungkin awak tidak tahu sama ada dia mengalir ke bawah atau ke atas. It's okay. Okay, you show the direction and you just assume it. Because in our calculation, we know whether our direction is in the right direction or in the reverse direction. I will tell you how to determine whether the direction is correct or not later on. It's okay. For the first time, you just guess the flow direction. And let's say this is another flow here. So we have another flow here. And for sure the output is this direction. Okay. So and then, okay, let's say usually the value of K is given. Okay, but sometimes you will get the value of F. So if you find that the question is not given in terms of capital K, means that you need to calculate the value of K by yourself by using the value of F, friction factor, the length, the diameter, and another parameter. Okay. Okay, so this is the value of K. It is given in this question. So and then you just write down the predicted or the assumed flow rate. So in this case, so it is 60, 40, 15, 55, and 20. So and then you calculate the value of HF. So the value of HF is just you multiply the value of K here. Okay, you multiply the value of K here with the value of flow rate Q square in this column. So you will get it is around 3,600 because the Q here is by the power of 2. Okay. Make it clear here. Okay, so after you calculate all of this, okay, then we are calculating using the delta Q equation. So this is the equation of delta Q. So it is a sigma HFC minus sigma HFCC divided by 2, and then we have a bracket here. Okay, so it is a sigma HFC over QC, HFC over QC here. Okay, then, so we start to calculating because we have two loops, so it means you need to differentiate the two loops. Okay, we start with the loop number 1 here. So I think I scroll down a little bit. Okay, I hope you could see this. Okay, so what is the meaning of sigma HFC? So, okay, sigma means you need the summation, you need to sum it. Okay, so you need to add all the value, and the C there is the clockwise. Okay, let's say we go for this, we start from here. Okay, and then if we go clockwise like this one, so we will found that, okay, I will show like this. So for at this side, okay, the flow is clockwise. That why we take it is in positive 1. So which is the 3600. So it's assumed here. Okay. So and then if we go to this pipe, so this flow is also clockwise. So and then we add with 675. However, when we go back to here like this, we found that the flow is actually the reverse direction of the our main direction, our clockwise. So because we are doing this C, okay. So and then we minus it with 3200. Okay. Say this is the meaning of total losses for clockwise of this one. Total losses of clockwise. Okay, I delete. So we have a total losses of clockwise minus total losses of counterclockwise. So in this situation, the 3600 plus 675 is the total losses for clockwise, and the total losses for counterclockwise is 3200. Okay, I hope you could get it. So and then we need to fulfill the HFC over QC plus sigma HFCC over QC. So for the bottom terms here, it's quite easy because so it not involve the minus sign. So we just add all of the parameter. So I delete all of these. Okay, so for the losses for clockwise, so here is the losses of clockwise, mean HF 3600. So here is 3600, and then we divide by its flow rate, so which is 60. So we have a 60 here. And then for this one is 675. So we have a 675 divided by its flow rate, so it's 15. And for the counterclockwise here, so there are no negative sign, so the value is 3200 divided by its flow rate, so which is the 40. And then you calculate all of this one, you times by 2, you will get 370 value. So for the first one, okay, you will get 1075. Okay. So, and then we need to calculate all the value because the value is the delta Q. So the delta Q is you divide 1075 with 370 means you get 2.91. So what is the meaning of 2.91 is the delta Q is 2.91 liter per second. Okay. And then you do the same calculation for the loop number 2. So you will find that, for example, we start with 800 B to D. Okay, so we start from here. We start from here to here. So it is clockwise. So the value of B to D is 800. Okay, however, if we go like this one, so the flow is actually reverse, so we minus it. And then if we go to this direction also, the flow is minus, so we have a 2 minus term in this equation. And then if we do this one, we will get it is equal to minus 2900. So it is okay for us to get the negative value. So and then if we solve the bottom part here, okay, so we could get it is equal to 280. Then if we divide these two value, we get it is minus 10.36. So again, this minus 10.36 mean this is the delta Q. Mean the difference between the counterclockwise and clockwise for loop 2 is 10.36 liter per second. So it means that according to this value, 2.9 is quite big and 10 is actually not acceptable because 2.91 is a 2 liter per second. So mean for every 1 second, the difference is 2 liter. Because 1 second is very fast, so in 1 minute, so might be you will have 2.91 times 60. So around 120 liters per minute. The gap, the difference between your calculation and the real one. So means 2 liter per second is quite big, and 10.36 is actually not acceptable because it's 10 liter per second, mean for every 1 minute, so you will lose around 600 liter. It's quite amount of fluid. So what you need to do is okay, this is not the final answer. So what you need to do is to close this iteration means you need to do this one. For the clockwise, you need to subtract. You need to tolak because at the beginning, we assume that clockwise is a positive. Now, to balance it, for the clockwise, you need to minus it. And then for the counterclockwise, you need to add because at the beginning, we assume that counterclockwise is negative. Okay, so how to add them? Okay, first you need to understand it is you must to subtract with delta Q, and for the counterclockwise, so you need to add with the delta Q. Okay, so what you need to do? First, you draw a table like this. So and then for AB here, the flow is negative, clockwise. And the flow is clockwise, then we need to minus with the delta Q. Okay, AC is the counterclockwise, then we need to add with the delta Q. Okay, let's see the graph here. Yeah, okay. Okay, from AB here, so it is clockwise. So because it is clockwise, we need to minus with the delta Q. So what to minus? So we need to minus the 60 here with the delta Q. And then here, so here the flow is counterclockwise. So counterclockwise, we need to add. So mean we need to add 40 liters per second here with the delta Q. Okay, and also for this one, for example here, So the flow is clockwise. So we need to minus with the delta Q. Okay, for loop 1, you need to minus or you need to add with the delta Q of loop 1. And loop 2, you need to minus or add with the delta Q from loop 2. Okay, so I hope you can understand this one. And then it is very special for this pipe because this pipeline is actually share with loop 1 and loop 2. Okay, so what we need to do is we follow these rules. Okay, so for BC, okay, we just calculated only once. Okay, BC, we found that for loop 1, so the flow is clockwise. Then we need to add, we need to minus them. But for loop 2, the flow is counterclockwise. So means that we need to add with the delta Q. But be careful for minus here because it clockwise direction in loop 1. So we need to minus with the delta Q of loop 1. And then for the counterclockwise here, okay, we need to add with delta Q, but this counterclockwise is actually for loop 2. So we need to add with the delta Q from the loop 2. So we do the calculation. Over here, as I said, so we have 60, so we minus with 2.9, we get some value. 40 times 2.9, we get some value. So here we plus with negative, so it's we deduct the value. We have a 20 minus with minus, so we have a sum here. So the value will be increased. And then for the BC here, so we minus with the delta Q from loop 1, and then we add from the delta Q from loop 2. Okay, it still we have a minus and minus, so we have a 1.73 here. So after you get this one, you need to draw. Okay, you need to draw another flow rate here. Okay, and this value is from this value. So if 77.09, so this is 77.9, this is 42, 44, and 137, 30.6, and so on. Okay, so this is your answer, not your final answer, your answer for iteration number 1. Okay. And then because the delta Q is quite big, 2.1 and 10.36, so means that you need to do another calculation from start with this value. Means you need your second iteration. Okay, so setelah awak kira, so awak tahu flow rate masing-masing, so you could determine flow rate for each pipes for each pipes. So what you need to do is you need to write as this one. So maknanya awak kena buat diagram macam gini. So and then awak tentukan kadar alir dia 57.09 di sini dan sebagainya. So di sini awak boleh check. Okay, you could check whether your answer is satisfying the continuity equation or not. Okay, so the idea is like this. So if you see, this is 100 liter per second. So if we add 57.09 with 42.91, so the total is 100. So and then here 59.09, so it is equal to 25 plus 30.36 and 1.73. And for this one, 1.73 plus 42.91, so it must be equal to 44.64, and then 44.64 plus 30.36, so it must be equal to 75 liter per second. So means now the continuity equation is fulfilled. So means that these numbers is actually can be considered correct, but but your delta Q is quite big. So your delta Q is 2.91 and another one is delta Q is minus 10 from 0.91, for example. So the value is still big. So what you need to do is to get the precise numbers, you need to do your second iteration. So for second iteration, from where you need to start, so you need to repeat all of this section, all of this calculation, but from here, you start here, you just replace this, value with the value that you get from your first calculation, so which is 57.09. So you just replace here as 57.09, and then you replace this one, and also this one. And then means that from this table, you need to replace this table with all the value that you get here. And then you need to start your calculation again here. So the value of HF is not changed because the value of, the value of HF also changed because the value of Q here is different. So awak akan ada nilai HF yang berbeza di sini. So awak akan teruskan pengiraan di sini dan seterusnya. Okay, boleh. Dan akhir sekali awak akan dapat nilai delta Q yang baharu. Kemudian delta Q yang baharu awak gunakan hukum yang sama. And then awak propose buatkan semula pengiraan ini. So awak akan dapat lagi satu nilai flow rate yang baharu. So ini adalah setelah awak kira kali kedua, awak propose nilai flow rate yang baharu. Ini nilai tersebut adalah jawapan flow rate untuk second trial. Okay, remember please remember that delta Q is not the final answer. So delta Q bukan jawapan akhir. Bukan sampai sini dah dapat jawapan, tidak. Once awak dapat delta Q, awak kena kira yang ini. Then awak kena propose flow rate yang baharu. Okay, ini dah dikira jawapan untuk satu cycle, satu iteration. Okay, cuma mungkin jawapan kurang tepat kerana delta Q makin besar. Okay, boleh faham ke? Untuk second trial, okay, and second trial pun awak tengok. Setelah awak propose, awak comparekan delta Q, kalau ada semakin yang ada lagi yang besar, so maknanya better untuk awak pergi ke third trial. Okay. Itu satu. Satu lagi ialah berkenaan dengan macam mana untuk kita tahu arah aliran kita terbalik. Contohnya, for example, so after you calculate this one, so you will find that it is not 1.73, but it is equal to negative 1.73. Then you may assume that, you may assume that this direction is actually wrong. Okay, the correct direction is actually this direction. So what you need to do is in your second iteration, okay, you just change the arrow here from the top to bottom direction to the bottom to the top direction like this. Okay. And then you maintain the value of the flow rate as 1.73. Okay, boleh faham Cara kita nak kenal direction kita untuk first assumption tu betul atau tidak, awak tengok jawapan awak di sini. Sekira jawapan awak ada negatif, membawa maksud arah yang kita berikan untuk kali pertama adalah silap. So jadi awak kena tukar arah tetapi maintainkan nilai, kekalkan nilai kadar alih. Jangan awak tukar arah dan letak juga negatif 1.73, tak nak. So saya prefer awak tukar arah and then awak hilangkan negatif dan tulis 1.73 sahaja. Okay, boleh faham ke? Okey, itu adalah cara untuk kita buat second iteration, third iteration dan sebagainya. Okey, pada saya agak tak sesuai untuk kita buat tutorial berdasarkan apa yang telah saya buat kerana starting tu saya dah pilih. Okey, so saya prefer awak buat, cuba awak buat yang ini. Bukan, awak buat yang ini.